Hello guys and welcome back to this tutorial series where we are going to create a climbing system like in Assassin's Creed. Today we are going to make a few checks, and those checks are going to be if you can reach it, if you can fit there, if, well, I think that's everything, yeah. And again, I'm going to do like, I think the perfect balance between performance and accuracy, but if you want to make it more accurate, just add more line cast, because we're going to work with line cast today a lot. But it's for me, it's just a shame of the performance. Also, you already see that they changed the scene. That's because it's the second time I'm recording. I'm very tired, so if you make any mistake, I'm sorry for it. But I just didn't sleep well, and I just need to record this before Monday, so I can upload it at the right time. So today we are going to create a function where we will check if you can actually go to the right place, what the actual edge is, and so on. This is not the here we already got like a function that will check for spots. We are not going to call it right here, so don't put it right here, because there's another function in between those two that will actually check if, for instance, if you hit this face here, you can't hang on that. That's, for everyone can see that that's just impossible, because it's the slope is so, the angle of the slope is so high that it's just impossible. But that's something that we are going to do next time. Today we are actually going to do the testing if you can fit there and so on. The very first thing we're going to do is create a public class array_info, and we are going to create this class because we need some variables of it, and we need some variables of like the arraycast itself, but not everything. And we also need something else that's called can go to point, and that's a bool. And that bool doesn't have like the normal arraycast info. It just doesn't have that info. So we need to create another class, and we're just going to assign from there. So array_info public factor 3 point. That's just a point. Nothing too special. Public factor 3 normal. So those two are just like in a normal arraycast hit, or yeah, that's what's called the official name, or just the info, the output. Those two variables are just exactly the same. But now we're going to add the variable that is going to make a change when the reason why we actually can't use the standard arraycast hit, and that is a public bool can go to point. Because what we're going to do is we're going to do in total 4 checks if you can go towards a point, and every time it can't go to it cannot go to a point, or because, for instance, you don't fit there, you can't reach it, and so on, it will just say it will just set this one to false, and the system will know, oh yeah, this one doesn't work. So we're going to create it here because move towards point is of course the last thing you're going to do. And this function is a public arraycast info, array_info I mean. And it's going to be called get closest point. And we need a few things for it. The very first thing is a transform trends. Am I recording? Yeah. Transform trends. Because we want to change the layer of it, and it's maybe a little bit weird, but that's why the scene is as this right now. So what we are going to do to find the edge is we're just going to send a physics.arraycast. We're just going to send a arraycast from this position here towards this position here. And where it will hit, it will know, oh, there's the edge. Because what we are actually going to do is found a spot right here, and just a little bit below it, just around 2 centimeters or so in this world, so just this, if it will just be like this, that's all it is going to change. A little bit less, so it will just hit for sure, because otherwise it will maybe just slightly not hit it, and it will just count as if it doesn't hit it, and it will get errors and with behavior and so on. But the problem is with this system that if the raycast will start from here, it will actually hit this object, right? We don't want that. So what we want to do is create a raycast that will only hit this object, and it will just ignore all the other objects. So what we're going to do is we are going to create, we're just going to change the layer to a layer that is only used for this, and then we're going to change the layer back again towards that it will only that what its old layer was. For instance, you got a layer for cars, so you know you can go inside that car or whatever, I don't know. You will want to change it after you climb this just back to that layer. Well, I think it's very logical that you want to know the position and the direction. But the position is not the position where the raycast will start, but it's the position where the hit, the function we created last time, found his spot. So this is the point. So we need to make some calculations to make sure that everything's alright. So the very first thing, what we're going to do in this script is going to, well, because we are going to we need to return array info. Yeah. So we are going to create a new array info, curl array, and that's a new array info. Again, this is one of those variables that you can call whatever you want, I don't care. Also, we want to have a raycast hit because we need an output. And we also need to know the old layer because we need to change it afterwards. And before, some people are going to be like, because the very next thing we're going to do is to actually change this layer. Before, people are going to, by accident, just put it here to change the layer before it will actually save the old layer. That will not work. You know, that's very logic, but before people are going to do that, I will just want to say that. By the way, here we're going to change this. Because I don't know which layer we're going to use in this tutorial series or which layer you are going to use. This is from my resource, where my resource scene or whatever you want to call it. I used this layer. We are just going to change that all in the last tutorial series. We're just going to do the whole scene thing, and we're just going to make sure that everything works. We're just going to fix every error we get and things like that. So the very first thing we are going to do is that raycast I just explained. So a raycast, because the position is not the position where you want to start, you want to do minus direction, because if you know the direction is going to be towards from here towards there, yeah, you know that if this is the point, you just do minus the direction and we'll get here, right? I think that's very logic. So that's where we know where we want to start. After that, of course, we're going towards the direction. And then we are going to have the output. And now we're going to do the how long the raycast is, so the length of it. And we're going to do that by, if you know the direction and from that the magnitude, you know how long the direction is. And we are just going to multiply by 2 because we want to make sure that we're actually going to hit it. And like I say, we need to do it only at this layer. But if you're just going to put here 14, for some reason, Unity will get, I'm not going to say that word, but Unity is going to not see this right. For some reason, it just doesn't work. So what we are going to do actually is we are going to add here a new layer mask, a public layer mask, and we are going to call it current spot layer. And now we are here at the very start of our script. We are also going to make a public layer mask called check layers reachable. We are not going to use it now, we're just going to use it well, in 2 minutes. So current spot layer. So now you got like it hits the object, and now what we are actually going to do is save it. Save like everything we need from this raycast. So we need to save the point. We need to set it to our ray info, which we are going to return. So the point is hit to.point, and the same with the normal. Let's also hit to.normal. So those two are just to get like because we need the normal and we need the point. It's just two things we just need. So that's why we have that, because we need to go towards the point and we need to find out if the normal, if the slope isn't if the angle of that is not too high. And now we're going to do, well, the very first checks. And I don't think, because it's my second recording, I'm not sure if I already explained it, but you got a face of a cube, and if you did, I'm sorry. And if you're going towards a line cast or a ray cast, and you start here and you go towards the cube, you will hit this face and it will just recognize this the point. Yeah, everyone knows that. But if you're from inside the cube and you're going outside, it will not hit the face, because a face is only facing towards one direction, and only if you're going from that direction, it will see the face. Otherwise, it will just not work. That's always also why with, I think, the older versions of Unity, I don't know if it's still there, but if you just place the cube or box collider and you was just standing inside that collider, you can just go walking around, and when you was outside the collider, you couldn't come back inside again. So that's kind of how it works. So that's what why we're going to do 2 line casts, and those line casts are, we are going to check if you actually fit there. So you can make this a little bit more accurate again by just, well, I'm not going to say it again, but the first line cast is from the right to the left, the second is from the left to the right. And I currently see that's not the very first thing we need to do. I'm very sorry. The first thing we need to do is actually going to check if you can actually reach it. And it sounds a little bit weird, because we already checked like it's in our range, yeah? But what if you got another cube right here, and it's just this. The raycast will just see this as, oh, you can just go here. But of course you can't, because we'll go, well, through our roof or something like that. So we don't want that. So we are just going to check with the line cast if we can actually go towards that point. So that's the very first thing we did. I'm sorry that I forgot it first, but before we're going to make this if loop, before I forgot it, I'm going to put here an else loop. And let me just see. Oh, it's already here. We also need to already put an else. Here it's trans dot the game object dot layer. We're just going to make it the old layer again, right? And after that, we're just going to return the query. And that's actually if it didn't hit it. So what we're actually going to do is we are going to also set the query dot can go to point to false. Something messed up, we can't go to that point. That's actually what it means. And we are going to create here, just in the end, because we can put like everywhere in the physics.raycast, we can just change this and well, it's a little bit of a waste. What we're going to do is we are going to copy those 2 lines and just put it right after this. So the only thing we are going to change now is this variable. Some people are going to ask, why don't you put it here? Again, sometimes Unicode just have weird bugs and errors. It just didn't work, so I created like this. So the very first line cast is a physics.linecast. And a line cast works, you give the the start position and the end position, and it will and it will just make a line cast between those. So the start position is the hand tram start position, and we don't need to make any weird calculations because it's not a local position. But we are going to make a transform the transition. We are going to make here a little bit of we're going to change here a little bit, because the thing we need to do here is if you're going to do it exactly at the hand transition position, it will be exactly at the edge, right? And it will just sometimes again give some weird errors, and a lot of those offsets are just because I discovered after, well, hours of just play testing this, or whatever you want to call it, that sometimes just get some weird things are happening. So then I'm just going to add those. This worked, so that's kind of how those offsets are. You don't need to do this, you can change it to whatever, but that is what for sure works. The second place is going to be the point, yeah, where you just saw there is the actual place where you want to be. And we're going to add a new vector 3, and also here's a little bit of an offset just to make sure that you don't actually hit the object before the point, which again sometimes there's just that little bit of a problem. And this, we're not going to use it, but otherwise we can't assign the layer mask. Well, you can actually, but for some reason again it gave some weird errors. And here we're going to put that check for layers reachable, because it's a little bit, you don't want every layer, but that's something of the latest tutorial part where I'm going to explain those 3 layer mask and how you need to set that up. And now we are going to say that, well, if you didn't, you can go towards that point, but there's a very big change that you actually did hit something. So then you can say the curray dot can go to point is false. But here we're not going to set true because we need to do 2 more checks. The very first one is from the left to the right, if you can actually hang there, yeah, which I just explained just a minute ago, from here to here and from here to here. So that are the 2 checks we're going to do just to check if you can actually hang there. So again, oh, very important, don't forget this, otherwise it won't work. I already know that there are some comments who forget that, or some people, and just say comment it doesn't work, but here it is. This is from, okay, yep, you got the point. That was a little bit Dutch, that was weird. And that's like the middle. So you need to go towards the left a little bit and towards the right. And now I'm going to do something that is going to be a lot of calculations. So what we are going to do is we know the normal. So it's of course that here it's going towards, if you're just going to see it from upwards, to the left of the right. But if you hang at if you hang right here, it's a little bit hard to see, but here's an edge, as you can see. You will, of course, the line cast needs to go from up to down and not from left to right. Yeah. So we need to rotate it, and we actually already know how which side we need to go, because we know the normal. And if you rotate it at 90 degrees, So we know that the normal is like this if you're just hanging here. So if you rotate it 90 degrees exactly, you will always get the line that is like exactly the same as the face. Yeah, it's a little bit, sorry, English. But here, and we're going to do it with Euler, and it's a new factor 3. So 0, 90, 0. Let's see, oh yeah, and we need to multiply it, of course, like I said, with normal. Oh, by the way, some may say, just because they are clever, yeah, you put here like hit 2 normal and everything's alright, but we already changed that here because we said that the output here is also hit 2. So don't do that, otherwise it won't work. And now is going to be something a little bit different of the normal things. It's this little bit you need to calculate by yourself. For this character, I know from left to right, if it's put his hands like in the air and things like that, it's the height of the character is 0.7, so half of it is this. So that is kind of like why this is happening. And so now you already got it. So the second thing we're going to do to make this whole calculation is we need to have from, if you're just going to put it exactly at the edge, of course it will hit something. It's exactly at the edge. So we need to make sure that's a little bit in front of it, so a little bit closer to the player. So what you're going to do here is you're going to do plus, and this is again just like trial and error. I think this is the perfect value. If you think differently, just do it. And whoops. So now you've got the point. So if you go you got like normal, so you got like this direction, and now you are going to use it because the normal or of the face is facing that direction, and you want it a little bit that direction. If you are hanging here, you want a little bit that direction, and so on. All right, so we now have that, and it's actually already the hardest part of this whole tutorial to understand, or not from this whole tutorial, but from this part of this tutorial series, because we can just copy and paste it here, because it's exactly the same, except that here is going to be a plus, and here is going to be again an out, hit 2, and here is going to be the check. Oops. Okay, come on. Check is reachable. Why is this an error? I probably forgot something. Yeah, it should be like this. I'm sorry. So if this, like this, if it does hit something, we need to change this again. And by the way, some people are going to say, yeah, this is just one line, so we don't need to add those two, but it will be really hard to understand if you're going back to this piece of code to understand what's actually happening here. So now we're going to do the second line cast, and that's going to be exactly the same. It's really just exactly the same, because the only difference is going to be that instead of this is going to be in, this is going to be a plus, and this is going to be a minus. So because you're going to do it from the other direction, so the start and the end are opposite of each other. And only now you can say can counterpoint is true. So now you just found out that you can go to that point, every path returns something, so that's also good, it also works. And now you got everything. So I hope you guys liked it. If you did, please leave a like or a subscribe. And that really supports this channel, so please do it. And I see you guys next time with another tutorial, or with the next part of this tutorial series. And well, if you just want more of this tutorial series, just smash that like button. And I'll see you guys next time. Bye!